All right, so take out a notebook paper. We're going to do free notes on solving radical expressions. Woo! So much fun. Contain yourselves. Okay, we're going to do an example. And we'll just list the steps for how to do it on the side. Okay, so let's say we have example 4 equals the square root of, okay, now we're getting tricky. Up until now, we've only been doing multiplication inside of the radicand. Now we're going to do a little bit of addition and subtraction. Okay, so outside of the radical, we'll have a minus 5. The first thing we want to do is we want to get the radical expression alone. Radical expression. Now when I say radical expression, I mean this alone. Okay, so I want this on one side of the equal sign and absolutely nothing else. So right now, I've got a minus 5 on the same side of this radical expression. So the opposite of minus 5 is plus 5. If I do it to one side, I've got to do it to the other side. Now I've got a 9 over here. And now my radical expression is all by itself. Okay, excellent. Step 2, we need to eliminate this radical sign. So whatever root this radical sign is, blue doesn't want to play today, let's do green. Whatever root this radical sign, we're going to raise the equation to the power of the root. I'm going to write the root in green. The root, or index, okay? Now you say, why in the darn are we trying to do that, Miss M? And I'll tell you, it's to eliminate the radical sign. Eliminate the radical sign, or the root. Okay? So, in the same way that addition eliminates subtraction, subtraction eliminates addition, multiplication eliminates division, division eliminates multiplication, taking some root and then raising it to that power eliminates it. Whatever power I have, if I take that root, it's going to be eliminated, okay? So let's just make ourselves a friendly little reminder. Ooh, how fun and exciting. Okay, so this is a square root. So when I say raise the equation, I mean the whole thing. I'm going to square this side, and I'm going to square this side. Now, anytime I square something that's a square root, remember, they undo each other. So on the left side, I'm going to have 9 squared. And on the right side, I'm just left with the radicand. Now from here, I'm just going to solve for the variable. Okay, so here's my variable. Subtraction undoes addition. Minus 4, minus 4. So we got 77 equals n. Final answer. Boom. Okay, not so bad. Let's try again. So this is example 1. Let's do example 2. Okay, so let's do one where, okay, 5 equals square root of 13n minus 1. Okay, now I like to put this little house, if you could see me, I'd be throwing down some little dabs like, bruh, this is my little house, you come with me, all you little people over here, choo-choo. So that I know this minus 1 is underneath the radical sign. I could have done that up here just to make it clear that, yes, everything that I've written is underneath the radical sign. Okay, so step 1, get the radical expression alone. Well, here's the radical expression. It's already alone. Okay, now it says raise both sides of the equation, raise the whole equation to the power of the root. This is a square root. So I'm going to square 5, and I'm going to square the whole expression. So on the left, I've got 5 squared. Well, that's just 25. On the right, I'm left with the radicand. And lastly, I'm just solving for the variable. Addition undoes subtraction. 26 equals 13n. That number is multiplying the variable I want to get alone. So the opposite of multiply is divide. Here we go. 2 equals n. Voila. Okay, so we can have a couple types of these. Let's say we have, let's draw a little squiggly line. Let's do a different type. Little froggies in the way here. Okay. So let's say, for example, 3. Let's say we have 2 radical expressions. 3a minus 8 equals square root of 2a minus 2. Okay, well, if the square root of this equals the square root of this, then really this radicand just has to equal this radicand. I can say, okay, well, both of these radical expressions are alone. Both of them have a root of 2. Let's just say I'm squaring both sides. So all that happens here is now I've got 3a minus 8 equals 2a minus 2. Trying to get both variables on one side, both constants on one side. Let's just go ahead and work left to right. Let's add this 8. So we've got 3a equals 2a plus 6. Now let's get this variable over here. So I've got a 1a, I don't need to write the 1. Here it cancels, equals 6. Okay. All that happened here is we already knew if I take the square root of this number, it has to equal the square root of this number, so whatever I'm taking the square root of has to be the same. Alright, let's try one that's a little bit trickier. Let's see what happens. Let's turn the page. For example 4. Ooh, how exciting. You can pause this video to finish copying, my dear students that always ask me to slow down. Thinking of you. I hope you guys are all well and I miss your smiling faces. Okay, let's do this example. So what happens if I say the square root of negative 5b plus 11 equals b minus 1. Ooh, tricky, tricky. Okay, this radical expression is already alone. So I'm going to take a look at the root, which is a 2. I'm going to raise both sides to the power of 2. Now, for the exact same reason that this does not equal 9 plus 4, because I know 3 plus 2 is 5, and 5 squared is 25. For the same reason that I can't do that, when I square this radical sign, I'm going to be left with just the radicand. But on the right side, I need to do b minus 1 times b minus 1. Because when I do 3 plus 2 times 3 plus 2, I'm going to FOIL first times both expressions in both terms in the second parentheses, times a second times both terms in the second parentheses. I get 3 times 3, 9, 3 times 2, 6, 2 times 3, 6, 2 times 2, 4. So here I've got 10, here I've got 15. Whole thing comes out to 25. So let's do the same here. Let's do b times both terms, negative 1 times both terms. On the left, nothing changes. 5b plus 11 equals, now here we go, b times b times negative 1. I don't need to write the negative 1. Negative 1 times b, I don't need to write the 1. And then negative 1 times negative 1. So from here, I'm just combining terms. Nothing happens over here. Now I have two linear terms. These combine to be minus 2b. Okay, now this is just a quadratic equation. When I'm solving quadratic equations, I want the equation to equal 0. So let's get both these terms plus 5b. That's the opposite here. Opposite of plus 11 is minus 11. May as well just do it all in one shot. So I'm going to add 5b minus 11 over here. This is going to equal 0. 0 is a number 2. Give it some love. Minus 2b plus 5b plus 1 minus 11. Okay. Now from here, you're just solving a quadratic. So, ways that we know, we can say quadratic formula. X equals the opposite of b, plus minus, square root, b squared minus 4ac, whole thing divided by 2a. Okay, we've got that equation. We can factor. And that's when I've got a times c, and I want a plus c. That adds to b. So let's see, negative 10. All right, I'm just going to factor this one. So my a is 1. My c is negative 10. So I want factors of negative 10 that add to 3. Well, positive 5, negative 2. Okay, so I'm going to rewrite this linear term using plus 5b minus 2b. So I've got 0 equals b squared plus 5b minus 2b, and then continue on with the equation. Gonna group. Divide both terms by the greatest common factor. So I've got b. Oop, erase that. Don't put that there. Alright, the biggest thing I can divide each of these terms by would be negative 2. So now I'm left with b plus 5. Now these are the same. Since it's the same, and I'm multiplying b by b plus 5, and negative 2 by b plus 5, I can say it's the same as this. So now I've got b plus 5. Ooh, I've been getting sloppy over here. Equals 0. And over here I've got b minus 2 equals 0. So I have b equals 2 for one answer. B equals negative 5 for two answers. Now, let's put in our step 4. So, if you get two answers, if two solutions, then you need to check for extraneous solutions. Extraneous solutions. This right here means answers that don't make sense. So, some examples of answers that don't make sense would be 2 equals 7. No, it does not. Another example of an answer that doesn't make sense. Okay, now, let's say I have the square root of 9 and the negative square root of 9. So, multiplying something by negative 1 is not the same thing as multiplying it by a positive 1. So we're only going to use principal roots. Principal, I think it's with an A, roots only. So that means square root of 9 equals only positive 3. Sorry, my pen moved. Okay, so to check, we need to plug both solutions into the original equations. Okay, so our example 4 original equation was square root negative 5b plus 11 equals b minus 1. Okay, so let's see what happens when we plug in b equals 2. So that means I'm going to put a 2 here, and I'm going to put a 2 here. So underneath the radical sign, now I have square root negative 5 times 2 gives me negative 10. 2 minus 1 is 1. Negative 10 plus 11 is 1. Okay, so this one checks out. Hooray, b equals 2 is an answer. Let's try when b equals negative 5. Okay, so if I put in negative 5 now, negative 5 in for b. Now I'll have square root. Here, let's draw a little squiggly. So now I've got the square root. Negative 5 times negative 5. That's 25. Plus 11. Equals, okay, negative 5 minus 1 is negative 6. Now, right away, can the square root of something equal a negative number? Well, we just said no. So that makes this an extraneous solution. Okay, so the only answer I have is b equals 2.